Okay, now, ang gagawin natin this time is we're still going to do a linear regression, but instead we're going to do instead of a single feature linear regression, we're going to do a multi-featured data set. Okay, so ito x versus y versus x, di ba? And we solve for theta naught and theta 1. Okay, so we solve actually for two features, theta naught at saka theta 1. Pero nilagay ko dito na single feature kasi yung sinosolve natin actually na variable dito is theta 1. And theta naught is actually called a bias. Okay, so for a multi-feature data set, ito yung mga x values natin. Okay, so we want to solve or we want to determine yung dependence ng miles per gallon, okay, to these features: acceleration, cylinders, displacement, horsepower, and I think itong weight. So 1, 2, 3, 4, 5 na x values, okay, na independent variables at isang dependent variable. Yung dependent variable natin is MPG, consumption ng gasoline. How is the consumption of gasoline affected by these parameters? Yung weight ng sasakyan, yung horsepower ng engine, yung displacement ng engine, yung number of cylinders ng engine, and then yung acceleration. Okay. So ilang features ang sisolve natin actually dito? It's 1, 2, 3, 4, 5 features. Okay, ang sinusolve natin dito. And then we also solve for the y-intercept, which is yung bias nga. Okay, na tinatawag natin. Okay, so how do we do this? First of all, yung data set na ito contains information na hindi naman talaga natin kailangan. Like for example, yung manufacturer. We don't think na yung manufacturer has anything to do with yung consumption ng gasoline, di ba? Yung model din ng kotse has nothing to do with consumption of gasoline. Okay? Even though yung model, okay, describes yung engine properties. Okay? But we want to look specifically at how the engine properties affect the fuel consumption, not yung model. And of course, the year that it was developed and the origin, okay, nung kotse, and this parameter. Okay, all of these have nothing to do with yung fuel consumption. Okay, so ang gusto natin gawin is tanggalin natin yung mga tawag dito yung mga parameters na yan. Okay. Furthermore, if you look down, if you scroll this down, okay, titignan natin yan mamaya sa code. Sa bandang 11, 12, 13, 14, 15 or na rows, meron itong mga not a number. And AN is not a number. Dun mismo sa ating tawag dito, Y value. Okay, we also want to remove that. Okay, so ang gagawin natin is, when you get the data, you don't immediately feed it dun sa algorithm nyo, dun sa pag-fit. We want to process the data in such a way that you remove those things, okay, na hindi nyo kailangan. So this is called data pre-processing. Okay, and this is actually the most time-consuming step pagdating sa machine learning. In fact, it would take you a lot of time, depende sa amount of data na meron kayo. And when you've already cleaned the data, yung algorithm na kailangan mo for machine learning will only take you just, 5 to 10 minutes. Okay? So, ang bulk ng time na kakainin sa pag-code mostly ay para lang linisin yung data. And you'll see that in a little while. Okay, so when the data is already cleaned, okay, ganyan na yung magiging itsura niyan. Okay, so nilagay ko dito sa 6th row, 6th column yung ating y, yung dependent variable, and then itong first 5 rows yung ating independent variables: acceleration, cylinders, displacement, horsepower, at saka weight. Okay? So, for single feature, yung equation na ginamit natin is this. Yung hypothesis na ginamit natin is this. Theta naught plus theta 1x. Okay, kasi isa lang yung x parameter. But this is a multi-featured na data set. So what we're going to do is, papalitan natin itong theta, itong x muna ng x1. Okay? And then itong theta naught, talagyan din natin ng x naught. Para masulat natin itong mga to into one compact equation. And then we set x naught is equal to 1 because it's exactly, if we do this, it will return exactly to this form, right? Kasi kung ito ay 1, then ito lang yun, essentially. Now, makikita nyo na if we write it like this, then we can write it in summation notation. Sum from I equals 0 to n ng theta I times xi. So if I is equal to 0, then you have theta naught x naught. And if I is equal to 1, then you have theta 1 x1. And then you sum yung mga yan. By writing it this way, we can write a hypothesis which includes all of these features. Of course, itong bias, so ito na ngayon yung tinatawag natin bias, theta naught x naught plus theta 1 x1 plus theta 2 x2 plus theta 3 x3 plus theta 4 x4 and plus theta 5 x5 is equal to the hypothesis. So yan yung buong equation. Of course, x naught is still 1. In MATLAB, how do you call itong mga itong mga elements na ito? In equation form, we represent these elements in like this. Okay, yung subscript describes the column number. Yung superscript describes the row number. So for example, if you want to call the first column and fourth row, the notation is x sub 1 super 4. Okay? Nilalagyan natin ito ng parenthesis in order not to confuse it with the power. Okay? Kasi pag wala itong parenthesis, you might think, excuse me, you might think that this is the power, this is the fourth power of x. So pag nilagyan natin ng parenthesis, alam natin na you are not taking the fourth power of x. This is the fourth column and ninth row element. Okay. So, ganun natin i-represent in sort of equation notation yung mga cells na yan. If we have this data set, then we can write the hypothesis like this, di ba? Now, paano natin ngayon isusulat yung cost function? The cost function is written in exactly the same way. The hypothesis is still placed here. We subtract that from the true value, then we square the difference, square the error essentially, and then we sum through all the errors, take the average, and that's how you solve for the cost function. Yung expression for the cost function did not change. Ang nagbago lang is itong hypothesis. Nadagdagan lang siya ng terms. Okay? So it's exactly the same. So in terms of coding, we just replace this with another summation. For the multi-featured data set, ito na yung magiging itsura niya. Okay, we just replaced it with a summation. Remember that we can write this as summation from, it's just equal to the sum, okay, of xi, sum ng theta I xi from I equals 0 to n. Of course, when you get the cost function, we need the derivatives. Now, instead of just 2 derivatives, since meron tayong 1, 2, 3, 4, 5 na features plus yung bias, then we have 6 derivatives. Okay, so we take the derivatives of the cost function with respect to all those 6 na features. Okay, so the generalization is the gradient with respect to theta I is equal to 1 over m times the sum from I equals 1 to m, okay, ng sum from j equals 1 to n ng theta j xji, okay, minus yi. Remember that this is the hypothesis. So, pinalitan lang natin yung h with this expression, okay, minus yi times x sub j super I, okay, where x sub j equals 0, super I is equal to 1. Okay, ito yung x naught natin. Okay, yun yung bias. Okay. Once we know the gradients, once we know each of the gradients, then we iterate this equation for all j's. Okay, from in this case from j equals 1 to 6, diba? Dito it says 0. Sa Python, this is true. Pero sa MATLAB, since you cannot have an index which is equal to 0, then you start from 1. In essence, wala namang nagbago sa code. Wala namang nagbago sa how you implement it. Wala nagbago sa expressions except for the hypothesis. Humaba lang yung expression for the hypothesis. Naging summation yung expression for the hypothesis. Now let's go to how this is implemented in code. Okay, so we have 1, 2, 3, 4, 5 features. And then dinagdan natin itong bias. Okay, so ngayon meron ng bias dito. This is x not is equal to 1. Okay, then this has 6 columns by certain number of rows. So this is let's say the number of rows is n. I think the number of rows here is 392. So let's say 392 by 6. Okay, so we have 392 by 6 rows. 392 by 6 na matrix. So express natin siya of course in matrix notation. Okay, kasi yun yung easiest. Okay. So lahat ng x values are expressed in terms of a matrix. Okay, and what we want to do to code it is ayaw natin i-type na sum na ganun. Kasi we can actually simplify it, okay, by using linear algebra instead. Okay, so the way to implement it is not by summing or typing the sum of theta xi. Okay, mas matagal yun. What you do is to write the matrix equivalent of this function. Okay. Okay, so remember that x naught is a column matrix. X1 is also a column matrix. X2 is a column matrix, and so on and so forth. So you want to multiply theta naught by x naught, and then theta 1 by x1, and theta 2 by x2, and so on and so forth. Okay. And of course, yung output mo is y, or in this case, ang hypothesis is h theta. Okay, so how do you use linear algebra for that? So, ang gagawin natin is, first of all, i-rewrite natin yung matrix X as this, X naught, X1 hanggang Xn. Where X naught is now a row matrix. Okay, X1 is also a row matrix. And Xn is a row matrix. So, ano nangyari dito? From a column matrix, gagawin natin, itong x naught, gagawin na natin siyang row matrix. Itong x1, gagawin natin second row. x2, gagawin natin third row. So, ang gagawin natin essentially is we're going to take the transpose of this whole matrix. So, itong buong natin matrix is x. But x is the transpose of this. Okay? So, itong x na to is the transpose of these. Okay? Yan. Okay? Okay. Tapos, so sabi natin kanina, no, this is a 392 rows by 6 columns. At pag tinranspose natin yun, magiging 6 by 392. So, itong x na to is 6 by 392. Okay. Matrix. Now, itong theta naught, 7 rows by 1 matrix. Now, obviously, hindi nyo pwedeng i-multiply itong dalawa na to. Di ba? So, kailangan yung kunin yung transpose ng theta t. At ang transpose ng theta t will be a 1 by 7 matrix. So, ito is a 1 by 7 matrix. At ito ay 7 by 392 matrix. So, h theta ngayon will be a 1 by 392 matrix. Okay. And h theta is the transpose of theta times the times this x matrix. So ganito na yung nangyari. Yung ating x ngayon is this. So kanina ito naka-column, ngayon naka-row na siya. So ito yung x naught. Ito yung x1, x2, x3, x4, tsaka x5. Okay, and then we have this MPG. Now, after solving for h theta naught, so na ngayon, ang h theta natin is now expressed in matrix form. Okay. And since y is also expressed in matrix, can be expressed in matrix form, it's also 1 by 392 matrix, pwede na natin subtract yung y from h theta. So this will give us theta transpose of x minus y. Okay? So yung buong expression natin dun sa bracket kanina, this one is now in matrix notation. That will make the computation faster. Instead of typing it yung brute force, solving for the sum in brute force, using brute method, we use linear algebra, and then we can make our computation faster. Okay? H theta ngayon is the seventh tawag dito, row dito. So this is the seventh row minus yung true value. Okay, how do we implement it? Okay, in MATLAB. Well, first of all, nung kinuha natin yung data from MATLAB, ganito yung itsura niya, di ba? So, if we wanted to multiply with the transpose, kailangan natin kunin yung transpose ng x, di ba? Kailangan natin kunin yung transpose nito. Kaya in code, we actually take the transpose of x muna before we multiply it by the transpose of theta. Okay? And then we subtract the transpose of y from all of these. Now, remember in linear algebra, transpose of a matrix is just the same as the matrix times this matrix. Lahat yan ay transpose. Okay, so this is nothing but yung property ng linear algebra. And itong transpose na to ay pwede nyong tanggalin. Okay, pwede ano ba? Well, i-factor out, so to speak. Okay, so now what we can do is multiply our x matrix by the theta matrix, subtract y from this result before taking yung transpose nung buong result. And that corresponds to this. Okay, dun sa ating cost function. Okay, then we take the square, okay, and then sum yung result. Okay. After that, we multiply yung coefficient, 1 over 2. Okay, so that's easy enough. Okay, so ngayon, ang ating cost function is written as this. 1 over 2m times the sum ng x times theta minus y squared. Okay? In Python, it's exactly the same form, pero we write it as np.sum times np.power minus np.x theta, x theta. Itong dot na to is just the matrix multiplication ng x tsaka ng theta, and then y. This reshape function sa MATLAB, sa Python, just converts y from 302 by 1 matrix to a 1 by 392 matrix. Okay? And then we return j cost dun sa cost function of function. Okay. Okay. Next, yung gradient. How do we solve for the gradient? Ito, alam naman natin na yung sa loob ng bracket, it's just x theta minus y. Di ba? Kasi ito na yung pinag-usapan natin kanina. Di ba? Sa loob ng bracket, it's x times theta minus y transpose. Okay, kaya dito meron tayong x times theta minus y. And then we multiply it by x. Okay, of course we need to transpose it. So x transpose times x times theta minus y. And then saka natin i-ano by 1 over m. So we don't need the summation anymore kasi ina-add by doing this type of multiplication, kinukuha na rin natin yung sum nito. Okay? So that's the beauty of linear algebra. Okay, so now we have the gradient of theta, and this will give us a 1 by 7 na matrix. Okay, then ang hypothesis natin is also 1 by 7. So ito yung initial natin na value ng theta, ito yung learning rate, ito yung gradient. So we compute theta, okay, for all we compute the new theta using this equation. And then, ang gawin natin is, ipasok natin yung bagong theta dun sa ating cost function to solve for the new cost function every iteration. Now, tignan nyo kung ano nangyari. Before, ang dami nating lines para i-compute, first of all, yung cost function, i-compute yung gradient, at i-compute yung theta. In Python, we write it like this. So pinakita na natin itong gradient ng theta. The equation for the gradient of theta is this. And this will this will update the values of theta. And then this will compute for the cost function. There's one more thing that I would like to add here. And this is what's called the feature scaling. If we take a look at this data, makikita nyo na yung data is, ang values niya is 12, 11.5, 11, 12, and so on and so forth. For the acceleration, for cylinders, it's 8. Displacement is ganyan kalaki. Horsepower is ganyan kalaki. And yung weight is even larger. And then ito hindi na ito gano'ng importante. So, if we keep the data as is, na ganyan kalalaki yung values, it turns out na sobrang bagal ng computation. Okay? So, medyo nahihirapan yung code or yung machine na i-compute yung minimum value if we have these large values. And the larger the values are, it will take even longer, and it is possible na pwedeng mag-diverge. So what we do to avoid that is we use what's called the feature scaling. Basically, ang gusto mong gawin is ilagay lahat ng values na yon within the range of -1 to 1. It's not so strict. Pwede ngang -1.5 hanggang sa 1.5, ganun. But the point is you scale it to a number that's this small, okay, para mapabilis yung computation, yung convergence towards the optimum value. Now, feature scaling is quite simple. Basically, yung dataset nyo, kunin nyo yung average ng dataset nyo, yung mean ng dataset niyo. Kunin nyo yung standard deviation ng dataset. And then, isubtract nyo yung mean from the dataset and then divide it by the standard deviation. That will be your new scaled dataset. Ito ngayon yung ilalagay nyo dun sa algorithm niyo as input. Okay? Para bumilis yung convergence. In MATLAB, you simply use the function mean to solve for the average, use the function std to solve for the standard deviation, and then this is how you implement this is how you get the scaled values. In Python, it's the same. You use the function mean, pero under numpy siya, na module. Yung standard deviation is the same. It's also under numpy na module. And then you compute the new scaled value of x by taking the difference between the x value and the mean value and then dividing that result by the standard deviation. This is the MATLAB code for multivariate linear regression. Now, yung dataset na yon is called CAR-BIG. Okay, you can download it from MATLAB. It's one of the sample datasets na available sa MATLAB. So we're going to load that dataset, okay, and then we're going to convert the dataset from a struct dataset to table. Okay, this simply shows kung ano yung first row tsaka fourth element, first row tsaka fourth column na element. Okay, and if you want to save the numerical value to a variable, then you use this command. Okay, kasi itong cars na to is naka-table, and yung indexing ng table is not through a parenthesis but through a curly brackets. Now, when you load the data, you also see these different properties. Okay, and you can take a look at these properties from the data set by typing in, like, for example, ito. Kung gusto nyo makita lang yung mpg data.mpg. Okay, so pag ginawa nyo yan, ipapakita nyo yung lahat ng mpg. Okay, so ganyan. Okay, so ganun lang. Anything that you see here, you can take a look at by simply typing data dot, and then kung ano yung gusto nyo makita. Okay, and then this tells you the first row, first row, fourth element. Here, we can remove those columns na hindi natin kailangan. So, ang ginawa ko is, nag-set ako ng variables na gusto kong i-retain. Okay, nilagay ko siya sa vars. And then, nagawa ko ng bagong variable na carbig, na kung saan yung content lang ng carbig corresponds to etong mga labels na ito with their values. Okay? And then this will just show me kung ano yung dimensions ng variable na carbig. Okay? So now we have a 406 by 6 na matrix. Kaya ito na yung carbig. And this should be yung acceleration kasi yun yung una kong nilagay doon. This is the number of cylinders. This is the displacement. This is the horsepower. And this is the weight. Okay, and the MPG. And kung tataka kayo bakit naka-decimal yan, well, this is multiplied by 10 to the 3. Ayan, 10 to the 3 times yung mga values na yan. So, now, kung papansinin niyo, if we scroll down, ayan, dun sa column 6, okay, specifically dito, sa MPG, sa yung MPG. Itong MPG, pagdating dito sa 11, yan, may mga values na ano, no, not a number. Ayaw natin yung mga values na yan, of course. So we want to remove that. And the way to remove that is just, first of all, tignan nyo kung ano yung mga elements na tawag dito. May values na not a number. So, is none, then carbig. Okay. So, if we scroll this down, ikita nyo na yung 11 to 15, yan lahat, yan mga not a number, and then yung 18th row, and so on and so forth, mga not a number yan. So, by using this command, you immediately determine kung ano yung elements ng matrix na may not a number na value. Then you find the index, okay, and you save the index in that, anong tawag dito, in this variable. Now, here's the thing. When you find the index, ang gagawin ng MATLAB is it's going to run like to the first column muna, and then second column, and so on and so forth. Hindi niya i-write yung index as 1 by 2, 1 by 3. Ang gagawin niya is just isang ano lang siya. Consider niya lang siya as one row. Okay, so since this is 406, so ito ay merong 406 na elements. Okay? Dagdag nyo to, 406 to, and then 406 yan, 406, 406. Okay? So lahat yan, walang not a number. Okay, so pagdating dito sa 6, this is most probably the 2041th element, okay? Na merong itong yan ay yung 2041th element. So 11 by 6. So 406 times 5. So 2030, di ba? 2030 plus 11, 2041. Oh, yun nga siya. So ito yung 2041st element na merong not a number. Ito naman yung 2042nd, 2043rd, and so on and so forth. So, hindi niya nililist as m by n, okay, yung index. Nililist niya to as one whole, tawag dito, matrix. As a single row or single column matrix. Okay, so you have to remember that kasi kailangan nyo identify kung aling matrix yung merong, kung anong index talaga. Okay, yung merong not a number. Okay, so yan yung list na yon. So merong 14 na elements na kung saan merong not a number. Okay? So we unflatten. So medyo flat. Naka-flat siya kasi it's just a single column, single row, single column. Okay? So we have to unflatten it, okay, by first determining yung by doing this command. So modulus ng idx temp with row. So this simply solves for the row number. Okay, so ang row dito, tingnan nyo, ang row is 406. So halimbawa, 1580 divided by 406, this will tell us the number of rows. And yung remainder, okay, yung remainder will give us the sorry. IDX temp divided by rule will tell us the column number, and then yung remainder will tell us the row number. Okay, so yun yung ginagawa nitong command na ito. Okay, then we delete these rows, okay, from the car big. Okay, so to delete rows, just simply type in yung variable and then yung row number na gusto nyo i-delete and then equate it to a null null element. Okay, so yan, ganyan lang. So mawawala na yung mga row matrices niya. Okay, so if we run this, then it will tell you kung ano yung rows okay, na merong values na not a number. Okay, kipansin nyo may 11, 12, 13, 14, 15 rows. Okay, and then we delete these rows. Okay, so na-delete na natin yan hopefully. Okay, and now we display yung cars again. So papansin nyo yung MPG no longer has these not a numbers. Okay, and then we plot yung mga features na ito against the MPG against its different features. Okay. Then we do feature scaling. So tulad ng sinabi natin, feature scaling is just taking the mean value, taking the standard deviation, just tawag dito, rescaling using yung equation na nakita natin for feature scaling. Okay, so we do this, and then we do feature scaling. Okay, we can take a look at yung function of feature scaling dito sa baba. Okay, so feature scale is just taking the mean, taking the standard deviation, and then subtracting the mean from the original X matrix and then divided by the standard deviation to get the new X matrix. Okay. Okay. Then, so ito na siya. Mapansin nyo, it's not strictly 1, di ba? So may mga 1, -1, -2. So it's totally fine kumpara sa 3,000 kanina na nakikita ninyo. Okay, so this will converge, allow the model to converge faster. We add the bias column kasi kailangan natin ng bias column dito which is just ones, di ba? So naglagay ako ng bias column dito. So ito yung ones na column. Okay, so ito na yung ating X ngayon. Okay. Now we implement gradient descent. So pansinin nyo na we have 1, 2, 3, 4, 5, 6 na guesses. Kasi meron tayong theta naught, theta 1, theta 2 hanggang theta 5. Right? Okay, and we use the first 6 columns as X and the last column as Y, as the output. Okay, so ito yung true values. Ito yung true values, sorry, at Y. We set the number of epochs to 1e to the 4. We set the learning rate to 0.001. And then we use the gradient descent function. If we scroll down, sabi natin yung gradient descent is just reduced to 3 lines. So ito yung 3 lines na nakita na natin kanina. Okay, so this just initializes yung J. This determines yung number of, tawag dito, number of rows, kung saan gagamitin natin to take the average. So once we have that, we can now run this and kita nyo, na-compute niya kagad yung optimum theta values. And na-plot niya rin yung cost function. Okay, now, pansinin nyo na the cost function reduces quickly after 1,000 iterations and then it slowly decreases up to 10,000 iterations. Okay, and now we're working with, nakita nyo na 10,000 iterations na yung ginawa natin ngayon. Kumpara sa ginagawa natin kanina na 100 iterations. And if you recall, when we did 100 iterations, it took us a few seconds para lang matapos yung computation. But here we did 10,000 iterations. It didn't even take a second. So ito ngayon yung theta corresponding to the bias. This is theta naught. This is theta 1. This is theta 2, theta 3, theta 4, theta 5. Sa MATLAB, we can use this function fitlm to solve for the coefficients or features na theta naught hanggang theta 5. Okay. So this function solves for the you can use it to a multivariate linear regression data set. Okay. So basically, you just set the output of this function to model, and then you can get the coefficients by typing in this command. Okay. here we have this coefficient. So it's also 6 by 1. So 46, think theta naught, theta naught, theta 1, theta 2, theta 3, theta 4, theta 5. Okay? Compare that here. Okay, medyo hindi sila pare-pareho. Let's just quickly take a look at Python. So here we have, well, ito yung functions na gagamitin natin. Okay. So, i-run ko na yan. Sige, habang nag-run. So, this solves for the cost function. Okay, pinakita na natin yan kanina. Ito yung matrix equivalent ng theta t x minus y. This is the square of that, and this is the sum of that. So this solves for the gradient, this updates theta, and this solves for the cost function. And ito naman yung feature scaling. Solves for the mean, solves for the standard deviation, and solves for the new values of x. Okay. And then here we have the modules that are necessary. Okay, actually just to compute for the gradient descent, the brute force, ito lang yung kailangan. This we need para i-pre-process yung data. Okay. And then the rest are for plotting and for solving for the theta values using machine learning. Okay, so nagawa na natin yan, na-import na natin yung modules. And then here, okay, kasi naka-load yung naka-load yung data sa Google Drive. So I have to give access to the Google Drive. Yes. Okay. Okay, so now that the data is loaded, we can now take a look at the data. So ito yung pandas na module. Okay. Ito, yung pandas, we renamed it as PD. So pandas.read CV, this opens this file CSV. Okay, so hindi siya mat file, of course. This is a CSV file. Okay, and we use the CSV file kasi nandun yung dataset. Okay, so ito yung dataset. Okay, and again, dilinisin natin yan, di ba? So kasi re-remove natin, tatanggalin natin lahat ng mga hindi kailangan na columns, and then tatanggalin natin yung mga data numbers. So this displays yung dataset. This displays kung ano yung mga tatanggalin. So we use drop to remove these columns. And then kung papapansin nyo yan na yung natira. Okay, and then we rearrange the columns. So yung kanina yung MPG nandito. Gusto natin lagay yung MPG dito sa dulo. Okay, and then we drop the not a number. Okay, and it's just a straightforward command. Okay, drop NA. Okay, and then we plot the results. Okay, now we do feature scaling. So for Python, this is how you use feature scaling. So data columns that apply this function to data columns para makuha niya yung bagong value. Okay? So, and nakita nyo na, yeah, less than 1 na yung mga values niyan or approximately equal to 1. And then we add the bias column. Okay, the same way that we did when we used MATLAB. Now we use gradient descent. Okay, so ito yung ating guesses, initial guesses for theta. 1, 2, 3, 4, 5, 6. Yung data kasi na ito ay hindi siya floating point. Okay, so kailangan mo siya i-floating point. So we convert it to floating point by just adding this dot to numpy, okay, na command dun sa data. Okay, and then we use the first six columns as x, and then the last column as y. Okay, so lahat itong variable na x tsaka y na to ay mga floating values na yan, floating point values na yan. We use 5,000 epochs, and then yung learning rate natin is 0.001. Then here's our gradient descent function, and then when we run this, again, it takes less than a second. We have these values. Okay, and then we can plot the cost function. Okay, ganun din yung result. It decreases quite fast, and then slowly decreases after 1,000 iterations. Okay, and okay, to get the y gra the gra the result, okay, the hypothesis, ito yung command na gagamitin natin. So ito is a multiplication. This is how we do matrix multiplication sa sa Python. Okay, and this is what we do if we want to use yung built-in linear regression function sa Python. And this is for machine learning. Okay, na ipapakita ko next time. So now we can, okay, now we plot it like this. Yung orange ay yung ginawa natin using gradient descent. And you see na ang pangit actually ng result gamit yung brute force na gradient descent na ginawa natin. Kasi ito yung true value, ito yung y talaga. And then this is what we obtained using yung gradient descent na brute force. Okay, yung function na ginawa lang natin. Now, I'm going to comment that out and, oops. Then this one. Okay, so ito naman yung gamit yung linear regression na function. Now, you using yung linear regression na function ng Python, you can see na medyo sumusunod naman siya, di ba? Kahit papaano. Okay? And if we now use yung machine learning algorithm, I have two machine learning algorithms here. Okay, so lagay ko na pareho. And makikita nyo na medyo nasusunod na rin siya. Except dito sa bandang dulo. Okay. And if we solve for the mean squared error, if we use the mean squared error as a matrix, so for our gradient descent, ganyan kalaki yung error. From linear regression, ganito lang kalaki yung error. And from the machine learning algorithm, yung unang machine learning algorithm, ganito kalaki yung error. And for the second machine algorithm, ganito kalaki yung error. Okay, now, okay, bakit ang laki ng error dito? Well, because we used this model is very simple. We just used a basic gradient descent. Gumamit tayong feature scaling. But like I said, ang dami pang ibang parameters na pwede niyong gamitin to tune the model. And that's what's missing here. Okay, dito sa brute force na gradient descent. Okay, on the other hand, ito ay built-in na function ng linear regression. But here, okay, ginamit natin yung machine learning algorithm, okay, to sort of tell the machine na i-figure out mo yung pattern. Okay, and the machine was able to determine yung pattern quite well with very minimal error. And yun yung i-discuss natin next meeting. Okay, so next meeting, ito na yung maiintindihan niyo. Ano yung mga yan? We're going to do that by doing classification. So next meeting, we're going to classify images ng flowers. Okay, 3 flowers. And then how do you use those images, okay, to train a model, a neural network model, okay, to classify yung mga iba't ibang flowers. Question. Okay, ang question is it possible to na-i-optimize din ang learning rate value po instead of constant lang siya? Yes, it's actually possible to do that. You can do that actually. But well, you also have to remember na hindi lang learning rate yung parameter. Marami pang ibang parameters na isa-set kayo pag nag-code na kayo in machine learning. And learning rate is just one of them. In MATLAB, there's called this experiment manager, which means that sa experiment manager, you can set ranges for the different parameters. Okay? At yung MATLAB na yung magsosolve sa inyo. For example, instead of running this code na paulit-ulit, so type mong 0.2 na learning rate, tas run mo, tignan mo yung result, i-type mo ulit yung learning rate na 0.1, run mo, tas i-type mo ulit. Sa MATLAB, you can set the learning rate initially as 0.1, 0.1, 0.2, 0.05, 0.1, tsaka 0.2. Tapos, let MATLAB do the coding. And then it will give you 5 results. Okay? So, ang tawag dun is experiment manager. Ipakita ko rin sa inyo yun siguro sa mga sa fourth or sa fifth na meeting. Okay? Sa Python, since it's an open source software, wala siyang ganong klaseng feature. But, of course, pwede naman kayo mag-create ng for loop. Okay? To iterate between those different values of learning rates.